Hello everyone and nice to meet you all today. So, without further ado, uh, I'm Erno Pirinen and I work at RoboCorp as the head of platform products currently. We are building the next generation so-called Generation 2 RPA solutions. I have a lot of background in RPA, but not so much background in test automation, but I think I know enough about that too, so I'm able to present you this. So, let's start with a real use case. So you are a test automation developer maybe, and you want to do some RPA case, maybe you got assigned one, or just want to do something else to find out things. So we could see like a little bit what do you need to be aware of when tackling those RPA use cases and how to build a sustainable development processes and like all the infrastructure needed around that to avoid the pitfalls in the future. So let's dig a little bit deeper to understand what's going on. So test automation, you probably are a lot familiar with this, maybe a lot more than me. But test automation is typically run in development environments. So the systems you are working with, you can mess around, you can input data, you basically want that system to break. Also, you have some preset input data and test cases that are usually predetermined. You have an idea how the system should work, and you are trying to test that the system works in that way. You want to cover as many interactions as possible. You want to see that there is no bugs. And if you find bugs, there will be exceptions which are logged, but like the execution of the test case, it could even end to the first exception. Also, you are trying to fix the target system. You are probably working with something that you can actually affect. So the end goal is to have non-bugs in the target system. Also, the users who are using the test automation, they're usually very technical. That might be the developers themselves or maybe a different quality assurance team. But here is where the differences start to pile up. So first, the idea of the RPA is business. So you are trying to automate a business process, a part of a business process, but basically it's a manual work or something else that is done to gain cost savings. RPA is usually run in production environments, so you are not able to break that system. If you mess up with the data, it is actually the production data, and you cause a lot of unintended stuff if your automation does something it shouldn't be doing. Also, the input data is usually very different for its execution. It could be orders or something else that come like every day is a new stuff you need to run. Also, you want to accomplish the task in the most efficient way. You want to do as little interactions as possible in the quickest time possible to achieve the end result. Also, the exceptions are handled. So in RPA, your goal is to survive. You want to have that order in that system or that monthly reporting done, and you usually can't just say that, okay, now something went wrong and, oh, sorry. And also, you are working with systems that you are not able to affect. So the target systems that RPA is usually done against, they can be really old. They can be SAPs from I don't know where, or old Java programs or mainframes. And those are like exactly the systems that are usually involved in RPA processes, because newer systems have APIs and other stuff you can build like straight up integrations with. Also, this big difference is that RPA actually has non-technical end users for the automation. So there might be the business clerks or somebody from finance department or customer success. They might not be at all aware of like what is a command line. Okay, so here is an example of what the typical RPA process could be. There is usually some input data, as mentioned. It could be maybe orders in email as an attachment, so you need to be able to fetch them somehow. There is usually some kind of a looping construct. For example, here it could be for each of orders, there could be a list of items that need to be ordered from the store. And also, the process owner might want to know, like, or control the process. For example, they might set that it's running on any Friday, but if the shop is closed on Friday, they might run it on Thursday. And also, if something fails, they might want to manually process that order, and they need to know what went wrong, so they are able to do that. And usually they also are interested in some business metrics, for example, how much time it takes to process these orders, or what's the failure rate, or stuff like that. So these are things that you need to take in account. So why should I even bother with RPA? Well, there are a lot of reasons. First, RPA, Robot Framework has a great syntax also for RPA. So the basic structure is very human readable, so you are able to present it to maybe the process owner or another developers who might not be very tech-like senior level developers, so they are instantly able to see what's going on with the process. And of course, both use cases interact with application interfaces, for example, APIs or graphical UIs. And as we all know, Robot Framework has a great set of libraries to address that use case. And if there is something you need to extend it with, you can use Python. For example, if your use case needs some kind of machine learning component, maybe to find out what's exactly in that order, you can import TensorFlow and go with it. Also, the logs are important, but a little bit for different reasons. Like in test automation, you are usually interested in what went wrong in a technical level. That's of course relevant also to the RPA, but in the RPA there could be, for example, auditing requirements. It could be under some regulations that you need to deal with, and the logging is actually a great way to see like what happened, when, and where. Also, there is a lot of like deployment options with both have similarities that you want to execute some code on a remote machine, and the Robot Framework has a lot of supporting tools for that. So what's missing for RPA? What do we need? What do we need on the top of a Robot Framework to be able to handle this kind of broad RPA cases? Well, you might need run triggers, and you might need some system to handle the data you are having in the processes. You need exception handling constructs. That's usually not done in the test automation as far as I know. There you need some user interfaces for the end users to be able to use the automation. Also some dashboards maybe for the metrics. And the big one is, and everyone's favorite always, is the compliance and regulation stuff that might come up suddenly. So, triggering bot runs. Business processes usually have some triggers for the execution, like coming from the business requirements when they need to be run. For example, here I have two examples. For example, whenever new customers are imported, they need to be processed immediately. Or monthly reporting is done at the last Friday of each month, so it doesn't make sense to run that robot, for example, every day, or when the repository of that robot gets updated or something like that. You could use schedulers. For example, weekday schedulers. The business person could maybe want that whenever they have a certain thing in their calendar, they want the robot to run. Or you could use cron scheduler to have like more definite time set when the robot needs to run. Also, APIs. Those are very useful in RPA. For example, start a robot with an API and give it some input data. And real-life use case would be, for example, integrating with a chatbot. Chatbot gives something to the robot does something, and passes the results of the execution back to that chatbot. Of course, there is open source solution like Jenkins that can be utilized for the orchestration, but usually they will need a lot of fine-tuning to fit the RPA world because they are designed with the test automation in mind. Well, let's see about the process data. So as mentioned, processes usually have some kind of data that the robots manipulate, input, or handle in other way. They could be invoices, customer IDs, or whatever is handled in that business process. And it can be in any form. We can't like trust or tell the business process owner that, hey, we only support REST API, so please give your business things in an API call. So the real life is that they could have emails or Excel files they have on their computer, or maybe something else from any system that is like the input data for the automated part of the process. So that brings the question like where to store the data, how to get it in and out of the robots. And basically to address that, we need some kind of a database and supporting systems on top of that. We need something to handle the data itself, maybe the customer ID. We need some status indicators, has the data been processed or not, and maybe something to flag the exceptions in a way that they can be handled later. And of course, a lot of other things that will pop up from the business requirements. There is usually a lot of open source databases available. You can use SQL or MongoDB or what's your poison. But for the use case itself, like handling the RPA data, there are not a lot of ready-made libraries. But we here in RoboCorp has made RPA framework, which is open source, and it has support for work items, which could be a great way to use that use case, and it also integrates straight up with our stack. Yes, let's dig a bit deeper to the exception handling. So during execution, anything could happen. Like you are working with system that might have a lot of bugs, there might be maintenances, there could be downtimes, there could be all kind of stuff that is just broken. So you want to survive. The goal is to survive, the goal is to get that order into the system or whatever in the most robust way. And also some of the exceptions that might pop up is due to the bad data. There could be, for example, missing shipping information or missing customer IDs. So the robot needs to be able to flag and handle those too. So, for example, the business process owner can then later on fix those things. And for that, we need exception handling constructs. And luckily, now, Robot Framework since version 5 has try except, which is of huge help of implementing these RPA use cases with a meaningful syntax that I can actually handle those use cases that pop up. And the usual practice is also to handle the known exceptions. You can set like, these exceptions are known that could happen. For example, login system could be down. What do I do in that case? If I'm able to handle that in the robot code, I should do that. But in the case that it's something that we don't know about, it's a random error, or it's just something that can't be processed at that time, those cases should be flagged for later on for human review. Which comes to the exception handling after the execution. So after the execution, if you have built the exception handling correctly in your code or according to some kind of best practices, there is typically like few categories that we can categorize the exceptions to. For example, the cases that need to have some kind of data error, they would usually need a review from the business process owner. So they go to and check that case, maybe fix some little piece of data there and retry it. Other thing is that they could have some unhandled technical error that we wouldn't be aware of, and those can be flagged for the developer to look. And also there is some things that we know that, for example, okay, this system was under maintenance and now all the cases we run failed, but we know also that that system will be up in 5 hours, so it makes sense to run them again then. And these exception types are usually known. The first one is called, in the RPA terminology, it's a business exception, and those technical exceptions are called application exceptions. So how to get that flow of exception handling those, including the users? Well, that's a bit difficult question, but usually you will need some kind of a set of databases, workflow queue systems, and UIs built on top of that. And also it's very useful to have the data in a transaction level, so like each whatever you process is one item there, so you can just retry or reprocess or handle just the subset you have, like with the exceptions, and you don't need to retry maybe all those 5,000 other cases, which when inputted in the production system would cause a lot of mayhem with duplicate entries and stuff like that. And of course, there is the end users who are actually going to use the automations, so they have some needs. They will need a way to provide their automation with input data. They might want to have that Excel file somehow to get into that robot without like developer always being in the loop. They might want to check the results of the processing so they know that, okay, now all of my orders are processed and I'm happy, like nothing to do here. And as mentioned, they might want to do some basic running configuration changes, so the UI would be needing to handle that. And also the business exceptions where they can just, the business process owners themselves can just fill in the missing data or fix that for retrying without having the developer always in the loop. And also the key performance indicators we already mentioned. Then everyone's favorite aspect that comes up in whenever you go work with production data to any bigger enterprise is the security, compliance, and governance. So usually when you start doing RPA, you are instantly bound into the organization's policies. They might have predefined security, compliance, and governance policies that you can't really affect in any way, so your system should be able to match those. Sometimes you might need some certifications. The department might require that every tool we use here needs to be SOC2 certified, or it's a no-go. And if you are just building something open source or using random stuff you have found anywhere, that could pose a little bit as a problem. Also, the data you process, it could be under GDPR or other regulations. That might mean that, okay, these persons can see it, these can't see it, and we shouldn't store this type of data, but this type of data can be stored. And these are things that you really need to be aware of when going work with RPA cases. And as I just mentioned, that can also provide a lot of challenges if you use something random and it doesn't have the needed compliance and governance and other certifications. So to address that, here in the RoboCorp we have built the control room, which is built from the ground up for RPA to handle the orchestration, and a lot of these things we saw before, so you don't need to fix all of those things yourself if you want to use this. So the basic subscription is basically free, so you can go try it out and have some simple automations running there. But the main feature is that you can basically run any code there, for example, robot framework, but we are really agnostic on that. You could run exe files or Java if you want. It doesn't matter. And we have a broad set of APIs built into the product, so you can integrate it to anything. For example, if you need a business process management layer on the top of your robotics, you could use Camunda, integrate that into Camunda or something else. Also, we have the work item system, which handles your process data and exception handling for you. So the developer doesn't need to code so much code to be able to have a robust exception handling in their processes. It basically comes built into the best practice templates. Also, we provide dynamic cloud workers for scaling executions and running without any infrastructure. So if you are working in cases that doesn't have, for example, SAPs or other stuff that needs really the Windows machine, there is a cloud infrastructure that is just one click away. But we, of course, support also running on those Windows machines for the use cases where you really have to use those. Also, the UX has been done so that it's non-technical person friendly. So basically, if you are able to use Excel, you will be able to operate the control room and handle, for example, business exceptions there. And also, the tool is SOC 2 and HIPAA certified. So if you are encountering those kind of compliance blockers, maybe the RoboCorp control room could be a way to solve those. And of course, that's not all, but we are on a limited time here, so let's go to the demo. So here I have a quick demo about the control room, and what you see here is some automated processes that are set up in the control room workspace. Here we have a workflow that has 2 steps, which are parallelized using our control room cloud infrastructure. So the first step, which takes in the Excel file, it just needs parallelism of 1, but the second step is going to use parallelism of 10 to efficiently process those. We can give the process input data via an UI or API or whatever, but in this demo it's a UI, which I'm going to give here an Excel file containing a lot of orders. Then we click process, so that Excel file is sent to the first robot for processing, and it's made as a work item, so we can track its processing status here from the control room UI. We can have any kind of data there, files, whatever is needed in the process, and those are always processed on a transaction level. And we have full history of what have been processed there, so we can see what is done, what is in progress, what has failed, and what kind of failures there might be into those items. And here we can see some example of the concurrency. We now have the Excel rows from the Excel files, which are these orders. They are now made as work items, which are pending for execution. You can see the execution here because it's done with the cloud environment. But for example, here we can now see that we set the parallelism 10. There is 10 concurrent executions going on, and each of those work items are distributed to a different robot to be run. And we also have like an UI here, where, for example, the business process owner could fix their code. Here, for example, it had a business exception. There were item that was not available, but we can fix the typo, and then we can just, okay, here is also like we have the robot logs available here for really easy troubleshooting. If you have technical exceptions, you can go see here instantly what's going on with your run, and you can just retry, for example, this one item you want to be fixed. And it will be run in like the same scope, so it doesn't affect the broader level of processing. And here we can see that most of the items are starting to get processed now, and that was it.